Ooh, sorry about that. I cut myself off. So at any rate, the derivative for sine of x is cosine of x, and the derivative of cosine of x is negative sine x. You will use these a bajillion times and you will have them memorized whether you want to or not. Okay, so let's do some examples. So the first one, I'm taking derivative of a constant. Remember what that was? I hear you shouting, I hear you shouting. Yay, you're right, it's 0. And on the second one, I want to find the derivative of x to the 5th. So, oh, it's looking like it's got a power. I call this power down. Sort of reminds me of Power Rangers. So I'm going to bring that power down and then decrease it by 1. That's it. Simple, huh? So now remember on this next one, I could rewrite this as y equals x to the 1/4 power, because that's what 4th root means. Oh my goodness, look, look, look. That is looking like an exponent. I'm going to power down. So y prime is 1/4. Brought the power down. And then I got to decrease it by 1. So 1/4 minus 1, I do believe that's negative 3/4. Of course, if we want to make that legal so that we don't go to jail, that negative 3/4 exponent cannot be, so I got to put that down on bottom with the 4. So 1 over 4x to the positive 3/4. And then the next one is missing an equal sign. Oopsies. Let's fix it. Oops, I guess I did fix it. That was an awkward moment again. Sometimes I think I hit pause and I don't. Okay, so now I can rewrite this as x to the negative 5th. And then, oh my gosh, got an exponent, so I'm going to power down. So the power's coming down in front. And then I decrease it by 1, aka subtract 1. And I can make that legal by putting it down on bottom. So simple. So this next one is really using your constant multiple rule. I don't worry so much about bringing it out in front. I just know that when I power down, I got to do something with them, and it would make sense, since those are already joined by multiplication right there, that I would just multiply. And that's essentially what the constant multiple rule is doing anyways. So when I power down, that negative 2 times the negative 2 in front is going to be a positive 4. And then I decrease the power by 1, so subtract 1 from it. There I go. And then I hyperventilate a little until I make that negative exponent a positive exponent. Ta-da! And then last but not least, I'm doing the sum. So essentially what I'm doing is just taking the derivative of each piece. That's all it said up above, right? So I'm going to start with the first term. And I notice it's got an exponent there. So I'm going to power it down, which means I have to multiply the 2 and the 3. So that's going to give me 6, and then decrease the exponent by 1. So now that'll be x to the 1st. I won't really write that later. Plus, then I do the next piece, powered down. Remember, that's currently a power of 1. So 1 times 2 is 2. And then I power down. That'll be x to the 0. Well, I'm not going to write x to the 0 because that's just really 1. And then subtract. Now remember, this is a constant, and the derivative of a constant is 0. So let's tidy this all up. I probably just could have done this in my head to start with, right? So 6x, I don't need to write the 1, plus 2, because that turns into a 1. And I don't need to subtract 0. There I go. There's my first derivative. Put another f prime of x in front of it. These are so easy, right? So on the next one, when they write fractions like that, it's so much easier if I think of it as this. That's got a coefficient of negative 1/2 in front. Okay, so then I'm adding, and I got some powers on each term, so I'm going to do each term separately. So when I do the first one, I'm going to power down. So 4 times that negative 1/2 would be negative 2, and decrease the power by 1. And then on the next piece, again, I'll power down. So I'll get a 9,